My name is Ilkka Lennon, and today we are going to discuss about different kind of integration scenarios. So let's see how to build ETL processes with a modern integration platform. But in the beginning, let's start going to what is Frends. On the right side, you can see our enterprise iPaaS integration platform as a service, PPMN 2.0 editor, which enables us capability of building low-code integrations. It's a browser-based. We have somewhat 200 to 300 different kind of integration capabilities inside the platform. We are capable of integrating to modern web services, REST interfaces, databases, Excels, PDFs, etc. We are able to access the different kind of file systems and able to integrate and orchestrate different kind of processes with the platform. We utilize low code to speed up the development, and that actually means that there's plenty of ready-made integrations available. The platform supports the DevOps thinking, so we have the design capability in addition to running production level services and monitor them and the healthy level of the processes. We are able to connect into different kind of multi-cloud environments, including ground on-premise environments with the segregated networks. And also we are capable of handling different kind of cloud infrastructures such as AWS, Azure, and Google services. And we can also build hybrid models. In addition to providing of modern API-driven applications, we provide support for robotics and also artificial intelligence. Our typical ETL scenarios include processing of data in different kind of formats, such as JSON, XML, CSV, flat file, fixed bit, or EDI. And today, we're going to discuss about different kind of integration scenarios. The common integration scenarios are point-to-point integrations. We can also discuss about shared data model and also single point of contact services. All of these are supported by Frends. We also provide support for application and data integrations, manage file transfers, and also ETL. We're going to also discuss about something related to distributed ELT process. So first of all, when we discuss about Frends and process automation, we discuss about orchestration of different kind of integrations glued together. In this case example, you can see a version of PPMN, which is a business process management notation, OASIS standard, which implements a process automation scenarios. On the left side, we can see that this process in the view is triggered every day at 1600. And the first step here, that when the process starts, we read the accounts from our CRM system. After that, we insert the information into the billing system and also into ERP. After the updates, we're going to notify the business owners, for example, by email or then a webhook into a Teams channel. We have some validation rules. Is everything valid according to the given criteria? And if yes, we end the process. Otherwise, we inform the process business owners about the validation errors. So this process has been built with a PPMN notation, and it's an industry standard for building up different kind of integration flows inside of your organization needs. So if we look a little bit deeper inside of the platform, in the first step, we are going to retrieve and receive the data from different kind of data sources. These data sources can be, for example, CRM systems, web services, REST interfaces, databases, Excel sheets, PDFs, Words, software as a service application, or product services. It's up to you where you want to retrieve the information. We have somewhat 200 to 300 different kind of integration capabilities for modern services. And all of these components are built with a drag and drop user interface. In the next step, we are able to update and insert the data. So after retrieving the information from the CRM system, we can then send that information into different kind of ERP systems with the modern interfaces, or then into the billing system. So what happens here that we actually extract the data from a database. After that, we do some transformation and reaching of the data, filtering of the data, and finally we load that information into two different targets. So in the third phase, we utilize the accounts inside the billing system and then accounts into the ERP system. So we transfer the data from CRM to both ERP and billing system. Here you can also see how Frends can be utilized with managed file transfers. Frends has been around over 30 years with a matured technology. It has been modernized through the time interval. And we are using independent product called Cobalt, which is part of the Frends nowadays. So with Cobalt, you are able to retrieve information from different kind of data sources like FTP, SFTP, FTPS, stream services, file system, and so forth. In this case example, what you need to do, that you need to just simply configure the FTP server address, credentials, the file, and the actual directory. After that, you retrieve the data and push that information to another place, to another directory with the FTP connector. So here you can see managed file transfer every 2 minutes with a simple Frends tasks, as you can see here. So the user interface looks very similar, as you can see on the bottom line. We have the visual monitoring, what actually means that when the process has been started, we can visually see what happened during the process. And we can also see the transfer logs. So we can monitor and handle events and errors inside the platform, just viewing all of the visual capabilities. We're going to look a little bit more about inside the demo. So here you can see extract, transform, and load scenarios. This is a very common way of sending information from one system to another. In the case example, on the left side, you can see that new order D96A is created. What we're going to do, that we're going to extract the information from EDI fact file. We're going to parse that information, and that is the extract phase. After the next phase, we are going to look, does it contain any errors? If there are errors, we are going to create an error message and send alert SMS and end the process. After that, we are going to transform. If everything is correct, we are going to transfer the EDI fact message to a JSON and send that information to a partner web service. And after that, the loading part is over. So we have all of the capabilities of extracting the information from EDI fact, transforming the EDI fact files to JSON, and after that, loading that information into a partner web service with a very simple process. So ETL is coming from words extract, transform, load. That's a very traditional way of managing point-to-point integrations from different kind of data sources into a one data warehousing. And when you discuss about different ways of transforming the data, you need to have a proper ways of managing the data transformation itself. The data formats can change. They might be coming from PDFs, Excels, Words, PowerPoints, databases, different kind of transaction databases, queues, JSON, web services, you name it. So there's plenty of different kind of data sources available. And when you need to have a proper ways of transforming that data, it should be simple and straightforward, as you can see within the Frends. After the transformation part is over, you can push that information into a modern data warehouse with the Frends connectors. In the extract, load, transform scenarios, the data needs to be published across different kind of segregated networks. So you can gather the information as a raw data from one data source or several data sources into a one place. You store that information with the system data lake. System data lake is something that gathers all of the relevant parts together and creates kind of a big data environment. So when you have a big data environment available for you, you're able to transform that into something personalized. You can also utilize artificial intelligence and machine learning. How we see it, that if you have a lot of different kind of big data needs, or you have a lot of information inside of your organizations, you can have several system data lakes inside of one huge corporation. You gather the relevant parts of the data, the raw data, into one big data system data lake, and then enrich that information and transform that information into a more business related through an API interfaces or similar. And you can also distribute that information across other organization structures. When there is a change, you need to somehow distribute that information and then distribute it. ELT might be something that you are looking after. So if you want to inter-exchange information, raw data, between two different systems, you can push the information from one system to another. One of the important facts inside of ELT process is that the data processing and reaching and filtering of the data happens as close as possible to the data source itself. So while you transfer the data from one place to another, you can start filtering, personalizing, using artificial intelligence, machine learning, etc., near the data source. So let's jump to see what it actually means within a distributed networking. Many of the systems are structured in a way that organizations are owning different kind of system parts. These different kind of systems owned by organizations needs to inter-exchange the data. Normally, there's lots of information that can be shared, but they have issues with security when transferring data. Normally, different organizations situated on different data centers or different countries are having their own data segregation networks and so forth. So the data needs to be distributed across the network. That's why we need to have event-driven distributed topics, where we have distributed producers and distributed consumers. So each site can have its own consumer of listening of changes happening inside of one organization. So what we do, that we extract the information from Excel sheets, Words, PDFs, REST web services, different kind of connectors, databases, CSV, etc., EDI files. We read that information. We push that information into an event-driven distributed topics. Then we have consumers which are loading that information directly into the actual database of the organization structure. And after that, the extraction phase takes place and the transformation takes place. Act as close as possible to the actual data sources. So this means that you can run Frends agents in a hybrid model nearby your distributed data sources. So we can build a hybrid deployment model which is supporting your segregated secure networks. So let's review what it actually means. So let's jump directly into a demo. Here you can see the Frends user interface, which is running on the Frends integration platform as a service. So let's review what does it actually mean. So we have a case example where we can retrieve information from a SQL server. After that, we are going to push that information into a modern web service, and finally use the ELT distributed queue with an ELT producer. So we start the process with the manual step. We could also read information from file. We can schedule every, let's say every Monday, 7 o'clock, or we can repeat that several times per day. We can also trigger by condition, HTTP interface, APIs, queues, and service bus. In our case, we utilized the simple manual triggering, manual starting. We can also have several different kind of scheduling windows and API triggers, etc. So in the first case, here you can see a Frends task, which is a simple drag and drop interface. So here's in SQL. We can drag and drop it on a place. What we need to do, that we need to have a connection string inside of Frends. We utilize environment variables, centralized environment variables to store the information about the connection string. It contains the server address for the database, the connection port, the username, and the password. And it's scripted and stored into a secure vault. We can call it through the environment variables. And after that, we want to write down the actual SQL, which is available here. So what we can do, we can build an integration test and run it through inside the platform. As you can see here, we got the result from the backend system. We did first fetch the first product from sales LD table. And after that, when the result is back, we're going to call a modern web service. So if you compare here, the previous result, the product ID, name, product number, and color, this is the extraction phase. What we do in the first step, that we utilize SQL driver to retrieve the information from a database. And after that, that database will be transferred into JSON. Frends utilizes all of the data what we have inside the platform in JSON format. So the result set is turned into a JSON. After that, we are going to make the actual transfer part available here. So what you can see here, that we have an XML format where we call the information as a message, name, size, the color, the timestamp, and so on. And what you can see here, we are going to retrieve the information from the name, the size, and the color from the previous step. Get information or get products from the SQL database. And we know that it's having specific attributes, name, size, and color. So here we can see the name, color, and then there's the size. So this information is very important for us. So we extract the information from the data source. And we are going to then create an XML, which will be then sent by using a REST request with a post method into HTTP or post. So we transform the result set coming from a database into JSON and from JSON to XML. And then in the final step, we do the same for event-driven systems. So we have an event push, which is a distributed ELT. So in our case, we are going to utilize RabbitMQ to send information into our backend system. In this case, we utilize the same data as before. We can see that the data is the same on both systems. So the message standard is the same. What we could do here, we could add a request message environment variable. And we could then push this information to there. Here we go. So we created a new variable. And this variable can be called from SQL. This request message is populated from the previous step, the previous result of the result set. Now, we can actually call the variable. Called request message. And we can do the same in this case. Now, when we make changes, we are having the first step here is what we call extract. The next step here is called transform. And final step here are the two loads. And also the same applies here. So in the last step, we utilize RabbitMQ, which complies with the distributed messaging. So we have one topic or one queue where you can send information. You can have several different consumers whom are listening the chains. And inside of segregated networks, we have several different consumers whom are listening to the change. When the change happens, we are able to push the information as close as possible into a data source, make filtering transformation using artificial intelligence, machine learning, etc., to reach the data and push that information forward and read that from the queue. So let's see what it actually does for us. You can see that let's run it once. And let's review from the monitoring window what's happened. Here you can see when we tune that we have successful runs. So let's review what happened during the actual transfer. So we triggered manually. We fetch the information, as you can see here, in the first step. All of the relevant parts of the products. We picked up the first product. After that, we are going to push that information, the transform data, into a modern web service. And after that, we are going to push that same information or load that information into a distributed ELT processing. And as we can see, it was a successful operation. So another case example. You can see here the EDF act to JSON example. So we again trigger the process manually. You can see a simple EDF act mockup message. And what we are going to do next, that we are going to parse that information and transfer that into XML. So in the extraction phase, we could read the information from file systems, databases, event push, modern web services, whichever is the data source for the EDF act. Then we are going to parse that information into XML. And we want to define that the output type of the system is the JSON. And after that, we're going to verify that does it contain any errors. If we are free of errors, we are going to push that information forward for HTTP REST service. You can see the transformation again. We read the results from previous steps of parsing the EDI fact files. We read all of the relevant part of the message and going to post that information into the backend system where the URL is given. We read the results from previous parsing of the information and populate the needed message. And after that, we are good to go. If there are issues, we can build an error message, send that information one of the administrators, and after that, we're going to end the message. And also, we can add monitoring windows on top of the platform. So that's all. That's all what we wanted to discuss today about how different kind of ELT processes, or or the modern ways of managing the distributed networking of different kind of data exchange. So if you have any questions, feel free to ask them.